So what if the way our minds actually work,
Yeah.
the mechanics of it, could inspire a completely new kind of intelligence, like a collaboration between us and machines?
Yeah.
Maybe so powerful it's like one single enhanced brain.
That's exactly the fascinating area we're jumping into today. We're doing a deep dive into the chapter Brain-Inspired AI Models plus Decision-Making Models. It's from your book, Computational Thinking, How Computers Think, Decide, and Learn When Human Limits Start and Computers Champs. Volume 1 by Jorge Guerra-Pires.
Yeah, exactly. And this chapter, it really digs into how AI is evolving by looking at the human brain, right, and how we make decisions. Dr. Pires lays out this really compelling view, suggesting we might even see a future where humans and computers kind of merge, creating that super brain idea.
And our goal here is really to unpack these, well, pretty complex ideas for you, make them clear, engaging. We want to pull out the key insights from the chapter, maybe spark some of those aha moments about where AI might be heading and how it connects to our own thinking.
Okay, so right at the start, the author throws out a pretty provocative statement, doesn't he? This idea that the 1970s, that might have been the last burst of human before robots, well, take over. It's quite a way to start things off.
It definitely is. It grabs your attention, for sure. And it kind of immediately sets the stage, highlighting this long-standing mix of excitement and maybe a bit of worry about AI's progress. Then he brings in that Moonlight Rendezvous song excerpt.
Oh, yeah, by Beast in Black.
Yeah.
That adds a whole other dimension, doesn't it?
It really does. The lyrics, this machine with a soul questioning its own existence if humans reject it, that makes you stop and think about the deeper stuff. Like, why are we creating AI? What's its real purpose?
Exactly. And the dedication of the book, too, to people who push their ideas forward even when it's tough, comparing them to figures like Einstein. That says a lot about the author's own drive here.
It suggests a real internal necessity, like Einstein's, to explore these big questions about human and machine intelligence. A real commitment.
So let's get down to it then. Computational thinking. In this context, brain, machines. What does the author actually mean by it? He uses that thought experiment definition.
Yeah, it's a neat benchmark he proposes. Basically, if you look at a solution and you genuinely can't tell if a machine or a human came up with it, that's computational thinking in action. It means the machine is doing something in a way that really mirrors how we might process it.
Kind of like a Turing test for problem solving.
Sort of, yeah. And Professor Kossobov's work, which is mentioned, suggests that, a lot of actual coding is already computational thinking, fundamentally.
Okay, that's a useful way to frame it. But then the chapter makes this distinction, right, between how computers think and how humans think. Computers solve problems we give them.
Right, predefined problems.
But humans. We can do that, sure, but we can also be creative, make up our own problems, think outside the box.
That's a really crucial difference. AI is fantastic at algorithmic problem solving, no doubt. Think Deep Blue beating Kasparov at chess, a perfect example of machine power in a specific rule-based domain.
Or AI composing music, like that bossa nova example.
Exactly. It shows a kind of creativity, but it's creativity within pretty well-defined limits and rules.
Yeah.
Human thought goes beyond that abstract reasoning, imagining totally new things.
But then, Morveck's paradox. That always throws me a bit. Computers nail the stuff that's super hard for us, complex logic, math.
Yeah, calculations, logical steps.
But they struggle with things a toddler finds easy, like just seeing what's in front of them or walking across a room without bumping into things.
Precisely. And this paradox really highlights the different strengths, doesn't it? AI has made huge leaps in reasoning, but replicating our seemingly effortless perception and movement, that's still a massive challenge. It suggests, well, very different paths for biological and artificial intelligence development.
Okay, so now the chapter moves into decision-making and the role of emotions, which is super interesting. Two scenarios are presented. One where maybe emotions get built into computational thinking somehow.
Right, maybe like adding a bit of randomness, almost like mutations in genetic algorithms, a way to introduce something beyond pure logic.
And the other scenario is humans and computers working together, but without emotions muddying the waters on the computer side.
Which brings in Kahneman's ideas, right? His work highlights how our human intelligence, our decision-making, can be really noisy and biased. Computers, potentially, could be cleaner, more rational partners.
But then you have Barbara Oakley's point. Sometimes people who think slower maybe don't have great working memory. They can actually be more creative.
Exactly. It complicates things, suggesting some of what we see as cognitive flaws might actually be tied to our unique creative sparks.
So maybe emotions aren't just noise. The chapters suggest they might be like ingrained guesses based on evolution experience.
Yeah, kind of like intuition built up over millennia. And if that's the case, trying to perfectly code that into an AI, that's incredibly difficult, maybe impossible. Would a purely rational AI have those intuitive leaps we sometimes rely on? Good question.
This leads nicely into brain-inspired AI and spiking neural networks, SNNs. The idea here is to build AI that's, well, closer to how our actual brain hardware works, right? Using these spikes.
Correct. It's about mimicking the process more closely, the way neurons communicate with electrical pulses or spikes. It's a contrast to deep learning, which is dominant now.
Deep learning gets results, but it's not really how our brains are wired, is it?
Not nearly as closely, no. SNNs are seen as more biologically plausible. Professor Kosybov, mentioned again, is a big name in this field. The author notes the initial excitement around SNNs. Maybe this was the path to truly brain-like AI.
Deep learning is just more efficient right now for solving problems.
Often, yes. For many current applications, deep learning models, despite being less brain-like, are just more practical and effective at getting the job done. It's a trade-off.
But even with deep learning, the author warns about its potential shallowness. That deep doesn't automatically mean deep understanding. The Google Translate example, Cabelo Feo.
Oh, that's a perfect illustration. The AI can translate the words. Sure, it's technically correct, Portuguese for ugly hair, but it completely misses the cultural context, the potentially offensive undertones that a human speaker would instantly recognize.
It doesn't get the meaning behind the words.
Exactly. It shows that even sophisticated AI struggles with that layer of human interpretation, context, nuance. It loops back to Moravec's paradox again, and it can do the complex translation task, but stumbles on understanding the simple social implication.
So does this then raise the question, do we really need AI in the way it's developing? What's the big advantage? The author brings up generality.
Right, that's a key argument. The potential for the same AI algorithms, the same fundamental approach to tackle problems across vastly different areas, image recognition, medical diagnosis, finance.
And transfer learning helps there too, right?
Mm.
Taking knowledge from one task and applying it to another.
Absolutely. It enhances that versatility. An AI trained on identifying cats could potentially adapt faster to identifying dogs, for example. The author does express some doubt whether older, non-AI algorithms could ever match this kind of broad applicability. That promise of a general problem solver is a big driver.
Which brings us right back to that core idea, the potential integration. Humans and machines. The superbrain. Professor Kosybov's vision is central here.
Kosybov talks about a truly symbiotic relationship, not just tools, but integrated partners where human cognition and machine computation work together seamlessly. The author sees figure 45 in the book as visualizing this emerging, a superbrain.
And it's interesting you mentioned Kasparov again. After Deep Blue beat him, he actually became an advocate for human-computer collaboration, didn't he?
He did. He saw the potential for center chess, human plus machine, being stronger than either alone. It shows that this idea of synergy isn't just futuristic speculation. People have been exploring it for a while. Of course, there are huge ethical questions, too.
Oh, definitely. The book touches on potential concerns, like the mention of AI-powered systems in some places, that raises red flags about control and misuse.
Very important considerations, but focusing on the potential. If we draw from both Kosybov's brain-inspired approach and Kahneman's insights on our own flawed decision-making, what does that synthesis look like?
Well, maybe AI design with a better understanding of how we think could lead to more intuitive collaboration.
Possibly. And Kahneman's work acts as a reality check. Our own thinking isn't perfect. So maybe AI can help compensate for our biases, our noise. The ultimate vision seems to be these integrated systems that leverage the best of both worlds, human intuition and creativity, machine speed and rationality to achieve more than either could solo.
The chapter also gives some concrete examples related to decision-making models. It mentions how sometimes really simple models, like basic regression, can actually outperform human experts. Kahneman highlighted that too.
Yeah, those examples are quite telling, aren't they? It kind of goes against the grain, the idea that more complexity is always better. Simple algorithms, free from human inconsistency and bias, can sometimes just be more accurate, especially in predictable environments.
And the attempts to add doctors' experience, clinical judgment, into models, that shows how hard it is to capture that subjective element, right?
Very hard.
Yeah.
It often turns out that the clean, simple algorithmic model still performs better because human judgment, even expert judgment, is inherently noisy.
And underpinning all this modern AI is data. big data sets. The chapter uses that college exam analogy.
It's a good analogy. Models train on vast amounts of data, like studying for exams, and then they're tested or validated on data they haven't seen before. But the key point is the data, the quality, the representativeness. It's everything.
And we need to be careful not to assume the model understands reality just because it finds patterns in the data it was fed.
Exactly. Correlation isn't causation, and pattern matching isn't true understanding. That's a crucial limitation to keep in mind.
Then there's the spatiotemporal aspect. Thinking about space and time together because, well, the real world happens in space and time.
Right. Many real-world problems aren't static. They unfold over time, across locations. The chapter points out that current AI might not fully capture this dynamic. The geometric shape sorting example is simple but effective.
How transforming the data, how you represent it, can make the problem easier for the algorithm.
Precisely. And since our brains naturally process information spatiotemporally, the question is raised. Why shouldn't AI models do the same to better grasp the world? It seems like a logical next step.
Okay, finally, the chapter wraps up by looking at the recent surge of deep learning and, of course, ChatGPT.
Yeah, it briefly explains deep learning, basically neural networks with lots of layers, and notes the combination of factors behind its success. Better hardware, huge datasets, algorithmic improvements.
And ChatGPT is presented as this big breakthrough in interacting with AI using natural language, based on deep learning and these large language models.
hmm The interview included gives a simplified idea of how it works, storing connections between words, predicting the next word based on probabilities and the context of previous words.
And that temperature setting, controlling creativity.
Yeah, that's an interesting parameter. Lower temperature makes it more focused and deterministic. Higher temperature allows for more randomness, more creative or unexpected outputs. It shows how we can kind of tune the behavior of these models.
So wrapping this all up then, we've covered brain-inspired AI, decision models, the limits of current AI, and this really big idea of human-machine integration, the superbrain. What's the main takeaway here?
I think the core message is the sheer potential. By looking to the brain for inspiration and by figuring out how humans and AI can genuinely collaborate, we might be on the verge of creating intelligence and decision-making capabilities far beyond what we have now. That superbrain concept, whether literal or metaphorical, really captures that transformative possibility.
It really does. And that leaves us, and you, with a final thought to chew on. As AI keeps advancing at this incredible pace, how will this potential merging of minds, human and artificial, change our very definition of intelligence, of creativity, maybe even what it fundamentally means to be human?
It's a profound question. We definitely encourage you to check out computational thinking for yourself, explore the original works by people like Kasabov and Kahneman, maybe even play around with some AI tools. It's the best way to start forming your own conclusions about this really fascinating and potentially world-changing future.